of no, right? We get the value on the left, value on the right, and we take and the root, and we take the maximum of all of them, right? Now, then the question is, what is the maximum value in the empty set? Yeah, the problem with null is that I give null to my buddies, and my buddies are going to put it in their equation, right? So think about this. Here's my node 3, and here are 2 empty trees, and I'm going max of this answer, and 3, right? And what answer do I want? I want 3, right? So what should I give me here? Now, somebody said 0, which is pretty good. But what happens if this is minus 3? Then I kind of like minus infinity here, right? Now, I'm a theory person, so I write minus infinity. I don't know what you do in Java. Right, everybody good with that? In fact, if you didn't quite get it here, right, so what's the maximum of minus 3, and negative 3? Right? The maximum is minus 3, right, which is kind of what you want. So here, if we're summing things, what's the sum you want to start with? 0, right? The sum of nothing is 0, right? What's the product of nothing? 1, right? What's the and of nothing? You want to start with true, because if you started with false, you're dead in the water, right? Once you got false and, it's false forever. So you want to start with true. While if we're doing ors, then you start with false, right? So this is saying, just to think about it, sometimes when you don't know what your base case should be, you go up one layer and you say, what value do I need here, right? I need the old product and the new one to be, right? I need it to work out. So you need true in there, right? Max, start with minus infinity, right? Min, you start with plus infinity. All right, so there's the code. Everybody good? Yeah? I've already said I don't do Java. I'm a theory guy. Anybody know if you wanted to do this actually in Java, what you would put there? You can do minus biggest number or something. That's probably a constant out there that you can. Yeah. Okay. So here we're going to have a loop, and I'm going to say s equals s times the next number, right? And when I start next number, what do I want to start with? Right? You got to start with 0 so I can pick up the first number. Right? That's kind of what we're doing here. What do I start with so I can pick up the first number? Right? Same with and, I want to start with true, right? Or I want to start with false, right? I'm just good to play with these. All right? All right, so here, height of the tree. It's kind of like depth, right? The difference is we're given the root. So, so we get the height, we get the height of the left and the right. Anybody want to tell me what the height of the whole tree is? The maximum plus 1. Exactly. Right? People see that? You want to say which of these is deeper and higher. You take the maximum, and then you get plus 1 because of that extra node edge up there. Right? What's the base case? All right, now we're talking about the height of the empty tree. And that's kind of, we were starting to draw pictures of that, right? But let's pause and let's work backwards. What's the height of that tree, right? Now, Jackie's code was going to say node 1 is of depth 0 and node 2 is of depth 1, right? So what would he give as the height of this? Maybe he would give 1, right? But I'm also willing to call it 2, right? Because there are 2 nodes. Are we counting nodes or are we counting edges? So, right? Is it 2 nodes or is it 1 edge? Right? So, and that's, in fact, that's why Jackie knew that this was an issue, right? And that's why in his thing, he specifically said the height of the root is 0. So we know, we have an example that we can work from. All right? So let's count let's count edges. Right? How many edges are in this empty tree? I don't know. Right? What's the height of this if we're doing edges? 0, right? The height is 0. All right, so now we want to say, what answer do I want here so I get an answer of here of 0? No, because the maximum of 0 is 0 is 0, plus 1 is 1, which is the wrong answer. We're wanting 0. Minus 1. Right? People see we want minus 1 in there. Right? So that says that the height, if you're measuring in edges, the height of the empty tree is minus 1. Right? And why are we doing this example? Well, some people count it this way. In fact, number of edges, this is the way that Jackie was counting it. But really, the reason I'm doing this is because it's weird, and it's good to see that weird things happen, and you got to think about them. Right? Everybody good? All right, so here's the code. It's just what we expect, right? We take the maximum of the height of the left and the height of the right plus 1, and the base case is either 0 or minus 1 or 0, depending on how we define the height of the tree, right? This one up here is measured in nodes, so we got 0 nodes, and we got minus 1 edges. Right? Everybody good? Excellent. You guys are really good at nodding today. I really fussed at the morning class, and I got them to nod some more. All right. Oh, this is just cut and pasted from Andy. No, what's his name? Jackie's slides again, right? So, right, he's doing height, and oh yeah, so he's defining height to be, let's see, if a node is a leaf, then the height of the subtree is 0. All right, so he's doing the same answer as we are, but he doesn't have a minus 1 in there, right? In fact, right, what's his base case? In fact, I would almost argue, we could get rid of this line. All right, but let's see what we have the line here. The line here says if if children dot length, right? That's not the notation maybe he wrote a routine to do it, right? This really should be children dot NOC. Remember, he had NOC was the number of children, right? But anyway, this is somehow the number of children. And if the number of children is 0, then I'm a node with no children. I'm a leaf, right? And I can return 0. Now, the reason I wanted the empty guy is because, right, for this node here, I do have a child, but I still have an empty tree, right? So I wanted the base case of the empty tree. But in his code, he's not doing binary, right? He has the number of children. So this node has one child. And so you just do its one child. And this guy here has no children, right? Yeah. Let's not go to dynamic programming. All right, so here's the code again. All right, so he's saying if you have no children, the answer is 0, right? Otherwise, we want to find the max of the bunch of things, right? So again, he knows that the heights will never be negative, right? So where somebody said 0 is your base case, right? So he started at the max of 0 instead of minus infinity, because he knows he's never going to get negative numbers, right? So, and then you go through, this is how, I remember doing this in Java. You got less than, which accounts for the -1, right? So you go from 0 to length -1, and then you calculate the height plus 1, and you take the max. Right? If max equals, holy Lord, that's scary, right? Let's see. Anybody want to parse this? Yeah, and then we got max here. So we're doing two things, I guess. Are we assigning?
Hello? Am I audible?
Oh. Right, this max equals assigning these values, right? So this thing here says if h is bigger than max, then assign h because it's bigger. Otherwise, assign max. Lord, why don't you just call the max routine? Surely there's a max routine. Right? All right, this is the stuff that makes me not want to code. Will you agree with me here? Reading other people's code. All right. Now, here, just amuse me for a minute and delete these first this line of code, right? And see what changes. I come in with 0 nodes. What happens? I set max to 0, and then how many times do I loop? 0 times. And when I come out, what's max? 0, right? Which is what I wanted. So I'm just saying you don't need that code. So he gets weird by this, and I would get weird by getting rid of that. See, we're all weird in our own little ways. Everybody kind of follow that?